2. Good morning, good afternoon, or good evening, depending on where you are in the world. My name is Julio Godinez, and welcome to today's DevOps.com webinar, Observability as Code, Go Faster with Automation using Terraform and Splunk, brought to you by Splunk. We have a great webinar for you today, but before we get started, I need to go through some housekeeping announcements. Today's event is being recorded, so if you miss any part of the webinar, you will be able to access the recording for on-demand viewing. We will be sending out a link to access the webinar on demand, or you can visit devops.com/webinars. We want to hear from you, so please feel free to send in your questions at any time throughout the program by using the Q&A tab. We also encourage discussion by using the chat tab, so let us know your thoughts or just say a quick hello. Finally, stick around until the end because we are doing a drawing for $425 Amazon gift cards, so stay tuned to see if you're a winner. Finally, joining me today is Kate Hymers, Staff Sales Engineer at Splunk. And with that, I'm going to put myself on mute, turn off my camera, and let you begin.
Okay, thank you very much, everyone. And welcome to this webinar on Observability as Code with Terraform and Splunk Observability Cloud. Let's quickly take a look at the agenda for today. So today we're going to cover off a number of areas. We are going to focus on Terraform. The way we're going to focus on it is by discussing how we can help you with strategically establishing observability within your observability practices within your organization. And we'll cover off a couple of areas in that respect and use Terraform as a way to establish those strategic practices and governance around observability. We'll take a look at the general dashboard design principles. So some of the things that you can do with Terraform is create dashboards and various monitoring practices. And then we'll look at reusability and standards, how you can set up different monitoring standards and practices, including how feedback is useful to improve on your monitoring and observability standards. And then we are going to cover talk a little bit about the tools and how you can use automation to improve on your observability, which is also what Terraform feeds into, and it supports a lot of that automation. So when we talk about observability as code, it's a lot of creating standards and creating automation. So we'll cover off that. I'm going to talk and cover off the slides for probably about 45 minutes. And then we're going to have a Q&A session at the end. So I'll go through the questions. So feel free to use the Q&A section to post your questions. I will go into those and then I'll answer as many as we can in the time that we have left. So a little bit about me. My name is Kate Hymers. I am based in Melbourne in Australia. I'm the SE manager for a sales engineering team within Splunk that sits in the smaller business unit called Observability. So we'll look specifically after the Splunk Observability Cloud and Platform Solutions. I've been a sales engineer for about 11 years. So I've got about 11 years of different conversations with different customers, different organizations, around different application development practices and application performance. And then I moved into APM area, and now that's morphed into overall observability in the last couple of years. So that's becoming a very popular term. In the past, I was a software engineer, so I was a developer. I've got a software engineering background. I finished a software engineering degree. So I can program. I like programming and coding. And I like sort of using that in the context of observability now. I came to Splunk by way of the Signal Effects acquisition. So Signal Effects was a smaller company that focused specifically on metrics and APM. It created a very fast streaming analytics platform for handling your metrics, and then it was acquired by Splunk in October 2019. So it's just been over a 2-year anniversary of me being at Splunk. So Splunk, if you're not familiar with Splunk, it's the big data to everything platform that covers a number of products. And then SignalFx has now been morphed into an offering from Splunk called Splunk Observability Cloud, which is an integrated platform now for your observability data. And observability data is your metrics, your traces, and your logs. Just a bit of a screenshot of one of the dashboards or views that's available in Splunk Observability Cloud. So Splunk Observability Cloud is a real-time cloud monitoring solution for your infrastructure, for your microservices, for your applications. It's a very highly scalable and performing. It easily supports the scale of observability data that's produced by modern and cloud-native architectures. So these are the architectures that are built using your microservices, your serverless functions. You're constantly scaling things up and down and making them more tolerant, and those applications are in a constant state of change. So the challenge with those applications is every time something changes or as you're scaling up and down, you're constantly producing more and more containers, you're constantly producing more and more functions that have their unique IDs. And as you produce metrics and traces and various data out of those functions, you need to be able to aggregate it to a service level or to some sort of higher level so you can see whether overall your applications and your services are up and running and your platforms are up and running. So you want to be able to keep track of that change and report it using high-level signals. So the platform is very suited for that, as it can support some quite high cardinality use cases. What you're seeing on the dashboard, it's only one of the screenshots of Splunk Observability Cloud. We've got a hotspot view of various infrastructure components. They're grouped by a specific service or a specific availability zone. And then you've got a set of charts that tell you how many servers or hosts you've got running. There's various aggregated information on that. That's just one view. There are other views. There's application performance management view. There's also logs in the system. So a bit of a lightweight version of what Splunk offers, more specific to DevOps use cases and troubleshooting. We call it Log Observer, so that's available in Splunk Observability Cloud as well. And what it does is it correlates metrics and traces and logs using their inherent relationships. So for example, if you've got a container, it's producing some CPU and memory metrics. It may be producing the application running inside the container is producing some traces. It's also writing out some logs. So you can link everything by container ID, or you can link everything by host if you go up a level. And that information is inherently related. So the little magic thing that Splunk Observability Cloud does is it's under the UI, it's a platform that also looks for relationships between the different data types, and then it allows you to link those relationships and troubleshoot a little bit easier. So that's just a little bit on Splunk Observability Cloud. And then why we are here today. So it's this provider here. So you can see there's, you'll notice the name SignalFx is still present in quite a few areas, such as this is what we call a Terraform provider. And we also call a number of scripts and resources that we provide within the Terraform. They are labeled SignalFx because this was created still before the Splunk acquisition. So there's still some legacy names that are scattered around. So with this providers, with the syntax and usage of this provider is something that you can check in the documentation. The documentation will provide a link at the end of this webinar. So in this webinar, we're not trying to show you how to code or a bunch of code, which can get a little hard to read. It can get hard to follow. It can be very small on the screen. So if you search on this provider, you'll find many resources that are available against it. You'll be able to see that with this provider, you can create things like detectors and dashboards and dashboard groups. You can set up lots of integrations. So for example, integrations with different cloud providers, integrations with different notification systems. You can administer. There's a lot of resources that offer administration options of Splunk Observability Cloud. So things like you may want to set up muting rules on detectors. You may want to set up integration with Slack. You may want to set up integration with Splunk on Call or any other notification systems, and so on. So you can do all that with a provider. There's quite a rich number of resources that is available to you. The more important bit is how and where you would leverage this Terraform provider and Splunk Observability Cloud in your organization. So I mentioned I'm not going to go into code, but I have to show just a little bit of code just to explain the different components of the provider. So this is an example of a Detector resource in use. So I'll just flash it on the screen quickly here. If you've used Terraform before, this will be a very familiar syntax for you. If you haven't used Terraform before, let's just briefly explain what you are looking at. So you are looking at a detector being defined using a resource, and this resource is then named application delay. It has a bunch of things that tell Splunk Observability Cloud and Terraform what to do, such as under what conditions we need to fire an alert. And you can see that in the program text, we write a lot of program. It's using a Splunk Observability Cloud language that's specific, a little bit Python-like. So if you're familiar with Python, you'll be able to read that. It's called signal flow. And you can see it's got a set of conditions, which probably not really relevant to go into here. And it has some detect statements on when to fire the conditions. And then also it has a set of rules that tell Splunk Observability Cloud when to fire this alert. So it's got a condition for a warning, it's got a condition for a critical, and then you can specify how to route, should this detector fire, under what conditions, which notification system to route the alert to. So this is ultimately all defined in the Terraform resource, and it tells Terraform what to set up when you execute it, and this alert will be keeping an eye on whether the application is slowing down, essentially, once you execute it. So let's just go up a level a little bit. And so when we talk about Terraform, we're talking about configuration as code, the configuration as code and Splunk Observability Cloud. As the name suggests, they underpin the practice of observability. And observability has got a lot of definitions floating around. It's a little bit like monitoring. It's not really. It's the production of the telemetry signals that all your applications and platforms should be producing. But then if you go up a level, it's a bit of an organizational sort of concept. So as a practice, it's mutually beneficial for all parties at your organization. So ultimate goal is that you want well-performing systems that benefit your customers, whether it's internal customers or internal customers. And you also want it to benefit the collaboration between the various teams at your organization. So ultimately, observability is a quality of a system. A system is observable if it outputs information about its operations and state. And as a quality, we can't separate a thing or a system from its observability. So to that end, you can look at this from either perspective, whether you are an organization with a bunch of standards, procedures, tools, platforms, libraries that you want people to adopt. And observability is a nice feature that can help you sell these things. Or maybe you're just trying to promote observability to some places where it's been lacking. So sometimes you start with observability as an overall strategy, but often observability is a consequence of you needing to get something performing, your systems, your applications. You need them to perform well. You've migrated to cloud-native applications. Every issue becomes a murder mystery. You may have heard that saying before, especially when you move to microservices. And observability is something that gets you to that stated goal of a well-performing system. So it mutually benefits you, benefits other teams, and it benefits your customers. So now we'll talk about something called strategic observability. So you can have your individual teams or individual developers or DevOps engineers that will build their own dashboards, will build their alerts on their own workstations. Then each of the developers or engineers will end up having their own version of how they want to alert on things, how they want to dashboard things. So you end up having this explosion of alerts and dashboards and a bit of a free-for-all market inside your organization in terms of how observability is practiced. But ultimately, we don't want each of those assets to work in isolation. You want to have a common language and a common way of looking at things and responding to problems. So today we want to talk about the strategy and how you can leverage tools such as Terraform to improve observability for your entire organization. So you're going to have a lot of decisions to make when applying the ideas in observability, monitoring, and the like. And we don't necessarily have the answers to all of them with tools because quite a lot of them are social problems, not technical ones. It's important to point out what we want to emphasize here. So buying or setting up a tool isn't enough. And explaining what SLOs are and error budgets are also isn't enough. So anyone on your team or in your organization can buy an SRE handbook and learn what an error budget is. But then you get to the devil in the details. How do you calculate properly the error budget for your specific set of services or your scenarios? What makes sense to you and what doesn't? How do you reach an agreement between the different stakeholders on what is important to measure using an alert and also to display on the dashboard? So it ends up being a difficult cultural change to implement, ensuring that everybody is using the same language and has the same understanding of the different terms and the different definitions that are used to represent the SLO concepts and the error budget concepts. Those tend to end up being quite specific to the services that you are offering, to the applications that you're running, and to the systems that you are monitoring. So there isn't kind of a one-size-fits-all SLO or one-size-fits-all error budget formula. It ends up being a negotiation between the different stakeholders in your organization. So we have to follow through as practitioners, leaders, and organizations to try and improve everybody's experience. And each team or individual making a decision on what the different aspects of their observability should look like alone is not really beneficial as a whole. So if we're going to be strategic, it's worth spending a moment to just deep dive in one little area of that's very prevalent in observability, and that's dashboards and how they should be designed. So anyone that's in some sort of engineering or development or observability role will have to build some sort of dashboards. But really, it's never part of the job description. You are just expected to go in and just throw a chart here and there and just throw together some sort of dashboard. So let's first of all take a look at some of the best practices around building dashboards. So essentially, dashboards are, what are they? They're a bunch of grids, and humans are very good at looking at and logically grouping grids together. So we just, without thinking, implicitly get them into their order that we would like. The most important parts tend to go to the top left. The less important ones tend to go to the bottom right. And this is kind of aligned to the way most languages around the world are read. So you're reading from left to right and from top to bottom. It's good practice to keep all the important elements in one screen. You don't want to have them be required to scroll down. And humans can't really keep more than a few things in working memory. So layout's quite important in the dashboards. And here's a little tip on what to put at the very top in the most important areas. So what you want to do is add your either read or use metrics at the top. If you're not familiar with those, read metrics are your rate, error, duration. And then your use metrics tend to be more infrastructure metrics like utilization, saturation, and errors. You would have heard this terminology before. There's another concept of metrics called Google's golden signals. And then they kind of red S, so rate, error, duration, and then saturation. So there's another flavor of that. But these are quite handy for watching your application health and also watching your infrastructure health. So rate will typically be the number of requests your service is serving, usually per second, sometimes per minute. But most of the modern metric systems will display them at a per second rollup rate. And then the error is out of those requests, how many have failed per second. And the duration will typically be a histogram of over a number of requests. How long did a specific process take or request take to fulfill? Then the utilization, so that's a proportion of the resource that's used. So you'll notice that a lot with CPU and memory. So if it's at 100% utilization, it means that no more work is going to be accepted by that resource. And then the saturation is the degree to which the resource has extra work, which you can't service, and it's queued. So things like network throughput, sometimes the disk space, so that can get quite saturated, so you want to watch those. And again, errors, so your infrastructure can produce a bunch of errors and you want to have a count of those events. So one thing to note is those read and use metrics, they're very important to watch. You got to recognize that they are very high level symptoms of a problem. So they're not telling you why a problem is occurring, but they are alerting you that the symptoms are pretty, the symptoms that need to be watched that will indicate that there's a problem with your system or application. A little bit like checking your temperature when you're not feeling well, and then you want to know whether you've got flu or just a cough or a cold. So temperature is a symptom, and then a cough may be a symptom, and then what is the underlying cause? You need to go to a doctor and diagnose that and do some tests. So the read and use, they are tried and true high-level indicators. And under that, you can put some extra details under those high-level indicators. So for example, if you've got an image or a video serving related application, you may want to add some image processing information and other extra details more specific to the application or the service that you are running. So knowing what's important and positioning correctly is not the end. Practitioners will rarely stop at the first dashboard or find the information that they actually need to get to the root cause of the problem on their first guess. Humans want to naturally jump to the next level of detail. So maybe an application map or a log search. You want to follow this mental model of how users perceive the system without them having to remember the system in their mind. So you want to add things like drill downs or maybe buttons or data links to your dashboard so that the users can naturally follow the trail that will get them to where they need to be. So we want to avoid these dead ends where we end up on a dashboard and then we have nowhere else to go, or we need to manually do that swivel chair effect and start switching to other screens and opening other applications in order to get to more detail. So how can I look from my higher level KPIs all the way down to my operating system metrics, or all the way down to the traces of my applications? How can I jump from those details to business logic? So you want to create those pivots in your dashboards so that there's a trail to follow in terms of where you want to troubleshoot. The next dashboards, they are highly perceptive, but they often lag. They will lack ways to answer questions. So you might want to link to some external tools, like maybe your BI reporting tools, to understand the next level of information. So support the linking of users to those tools via the dashboard in context. So what we mean in context is you take the filters from the dashboard, you might take the time window from the dashboard and push it to the next solution or the next step in the trail as they are troubleshooting, is very handy. So you want to avoid dead ends and also analytical support. So now that I've spoken in great detail about dashboards, because they are kind of the after the alerts or even before the alerts, the bread and butter of your observability assets. The next thing we want to look at is how do you make the processes around your observability repeatable and reusable? So you can go about this way by running a bunch of training and webinars over a period of time for your team to introduce them to a specific set of standards and get them to use a common language. This will take up some time. It doesn't really lend itself well to agility and change and just the kind of the scalability of the standards across the organization. So what you want to do is facilitate reusability in standards with modular capabilities. For example, a calculation of an error budget or a common set of dashboard components that will underpin all your services in some generic way. This will allow your users, rather than relying on training, on know-how and building out configurable components themselves, to take a set of reusable modules and then mix and match the modules that they need for their specific observability needs. And these tend to be generally set up by your SREs or a centralized observability team and supports the strategic common standards without relying on training up your workforce, so that the workforce doesn't really have to think about it. They just need to ask for what they want, and then we can mix and match the modules that they will have. And let's take a look at an example of how this would be done in Terraform. So Terraform has this concept of a module. This module over here provides some service baseline. So it will create a bunch of assets that will give us baseline visibility into your service. So if you look at some of there's essentially 4 components that are defined in this module. We've got a source of the module, so you give it a path. And then we have a version, which is a very handy component that allows you to, as you're developing a module, to introduce breaking changes. But then your users may specify that, well, they want maybe n-1, always want to work with n-1 version, or they rely on a specific version. So that way you can start breaking things, but this is not going to impact your users, and they can continue to rely on all the versions until they've tested the changes and can continue and can proceed with the changed components and be satisfied that the changes don't break their things. And then the next section, we've got 2 parameters. So modules offer this parameterization. We can over here, we're providing details such as our service name and our team. And then under the hood, what happens is this module then links into a bunch of common components. So in this case, it would be a bunch of dashboards and alerts. So for example, all your services are using Istio, or they're using SNS in AWS or some other common service. So then you can go ahead and build up the dashboards and the resources out of the different components for the specific service name and specific team. So with that module, what you can then do is start creating a dashboard that we have as an illustrative example here. So this is the type of things that you can build using a Terraform module. So there's a whole bunch of things that you can do without doing anything except giving your module a service name and maybe a team. And it goes off and pulls the required data into your dashboards and builds out those red metric charts and use metric charts. It can also go behind the scenes and do things like create a whole bunch of specific detectors for you, for example, to detect on SLO breaches. So in Splunk Observability Cloud, you can see there's what you're seeing on the screen here is a few green borders around some of the charts. So what it allows you to do is actually link detectors to your charts. So if there's a link between a detector and a chart, so for example, I've got my error rate chart, or I've got my latency chart, and if a latency starts to deviate and it starts to breach SLOs, I can fire an alert, and then as I'm looking at this chart, I can straight away see the border will turn red, and I can see there's actually an alert being fired, and I can quickly correlate that red color with any sort of jump in my latency. So it gives me the visual representation of what's happening, and I can make conclusions very quickly that something's changed, and now we have an alert and we have a spike in our latency. You can also annotate your charts with things like custom events. So custom events can be feature flags, for example, or code changes or builds that have gone out, maybe releases. So what this allows you to do is then if there's, for example, a latency spike or an error spike, we also have an alert that has been fired. And then we can also see on the charts the annotation or overlay with the events. So I can very quickly see that a code's been released or a specific feature flag has been set. And, and then I can start quickly making conclusions just by looking on the dashboard that the custom event that has been registered has something to do with this changing conditions. This kind of supports that with one visual, we can very quickly understand what the problem may be. These are some of the capabilities of Splunk Observability Cloud. And then there is a section, it's not visible here, but there is a chart type that allows you just a type of markup text. So there's a concept of data links. There's a concept of jumping to either traces or logs from charts. And there's also a concept of creating markups and hyperlinks. So that you can, from a specific chart, get to additional information that I spoke about. So if you need to go to a third-party solution and carry over the context, carry over the time window that you're searching through, also carry over any of the filters, you can do that through data links, and it's all on one chart. So if we need to explore further, for example, I want to have a look at what log information has been written, that's easily done through that chart too. So that's kind of an example where we provide just a service name and then the chart's created with Terraform. All the data links and the links are created with Terraform, and then the associated detectors are created with Terraform as well. So it becomes a one-click solution to get all these assets, and they are reproducible and reusable across multiple teams. So another person or another team might come in with their service name and they can get a set of dashboards that are exactly the same, but they'll link into the data sources for the specific service name. Okay, so moving on, there are a couple of other things with the charts that we want to do and we want to make sure that are there. And I've spoken a little bit about them on the chart features. So the dashboards and charts, you'll notice in the tooling and the various tooling in the Splunk Observability Cloud, it's not just single charts that are populated on the screen. They'll have a set of other UI components. And it's things like filters that allow you to slice and dice your data. So for example, I've got my just high-level service name, but then I want to sort of filter it or group it by Kubernetes clusters that they're running across, or maybe availability zones they're running across. So you want to allow for that as well, and that's what those filters and groupings allow you to do. And it's also very handy to add those events and annotations to your charts. So if your line charts are deviating, or if you see something's happening on the charts, you can start correlating that with the changes. And then you've got the additional charts and views. So if we just go back to this little chart, you can see I've got a representation at the very top of my line chart. And then I've got a detail of what is the actual current value in the last, say, 10 seconds or the last 5 minutes. So we've got this single value right at the bottom of it. So what this helps me to do is I can see that there's been perhaps a spike in rate or in latency, but I don't have to kind of put my mouse over a data point on the line to see what the latest one is. I can just lower my eyes and very quickly see that we've got the rate or the utilization of 98% and the latency of 397 milliseconds in the last 10 seconds. So that's just a usability aspect that allows me to really quickly get that information just with one look without having to do anything further. So that's what we mean on the additional charts and views in different representations, and then links to outside bits so we can follow the trail. So with those assets that we are talking about, those modules and the creation of dashboards and detectors and other assets that are relevant to observability, there are some kind of practices of, if you're managing those, to treat it like it's a product. So treat it like it's an internal solution that you are managing, so you can manage the change, you can make improvements to it over time, and you can also get user feedback, which will allow you to understand what's working and what's not working in your solution. So you kind of don't want to be that person that is just making changes and building out solution without any feedback, and you just mess up everyone's alerts. And then you're going to be the most hated person in the organization for doing that. So it's a good practice to manage their modules and the Terraform scripts using a change management system. So you can keep a log of your changes, and you can also ensure the control of config changes and backtrack any changes that are required. It's also important to, as a team, to celebrate the different achievements. So if you've implemented a set of common standards and they are helping the various development teams with their visibility and with their alerting, recognize that and celebrate those achievements. And as I mentioned earlier, it's the first detector you're going to create is never going to be perfect. The first dashboard you're going to create is never going to be perfect. So it's don't just leave it at the first iteration. Collect feedback. And we'll talk a little bit about each one of those in a moment. But one important thing on the feedback is when you implement the feedback, just follow up with the person that submitted it and check whether it's working for them. So if someone advises their alerts are too noisy and you've reconfigured their alerts to be less sensitive, follow up and make sure that the alert is working. So it's just some of the social practices around observability that are very handy to make sure that everyone's on board and everyone is working towards that mutual benefit. So let's take a look at more specifically on the monitoring of your observability solution and on collecting that feedback. So when a monitoring system is not monitoring properly, people get angry, usually at the tool owner or at the observability team. We tend to typically fall into this pattern of incident-driven development. When something breaks, we add an alert to it, and then we end up with alert storms and meaningless alerts that no one remembers the purpose of. There's a quote from a paper by Don Orman, the author of The Design of Everyday Things, where he complains about the state of the art in toolings and systems. Their complaint ends by saying, we do now one approach that doesn't help, adding more alarms. This advice is about 40 years old, but we're still doing it. We're just adding more and more alarms, and everyone's favorite punching bag is alerting. So let's have a look at some of the basics of how we can improve on alerting. So there are best practices around alerting, and you want to develop those and share those with the teams that are making use of them. And you want to do some helpful things. So alerts, they work on metric time series. They'll have a lot of math behind them. So you want to help the developers with some of the useful maths and also some of the patterns, such as how the signals operate, if there's a difference between the metrics that are quite a regular heartbeat versus the metrics that are more sporadic. For example, if you're looking at something like an error rate, it may have an error at random. So how do you actually, what would be the difference between identifying the patterns in a regular heartbeat signal versus a more sporadic heartbeat signal? And then when the alerts are firing, you want to add some helpful context to the alerts. So, for example, where are they firing from? And you want to pack as much of that context as is useful or as practical into your alert so that when it arrives, the person notified has a good starting point around where they should be looking at. So these are some of the areas that can make the alerts more actionable and more useful. And there is a bit of a methodology around that. It's called CASE, and each of the letters stand for how to assess the effectiveness of your alerts. So C stands for context heavy. So you want to pack as much context as you can into the alert to make sure that as you receive a notification, you understand where the alert is firing from, and it gives you clues as to where you should start looking or start investigating the problem. It also needs to be actionable. So if you're firing some meaningless alerts that don't have a runbook associated with it, that don't have next steps, where the developer or an engineer receives an alert that don't know what to do next, that's not an actionable alert. So you want to make sure that there's the next step after the alert, whether it's to a troubleshooting view, whether it's to a runbook, whether it's to anything else that will give them the ability to start taking action against the alert. And the alert should be symptom-based. So the symptoms, we've spoken about the read and use symptoms. So you want to understand what exactly is failing, what is, not what exactly is failing, but what is a representation of the failure. Is something being saturated? Is something about to run out of space or of bandwidth? Are the error rates too high? Is the traffic dropping? So these are the symptoms, and that's what you want to alert, and then dive into investigation of what's contributing to those symptoms. And then ultimately, the alert should be evaluated regularly. So what you want to do is review the alert and make sure that it's an effective alert, and as throughout the life of the alert, that it makes sense to continue maintaining the alert, and as that alert fires, it is allowing the users to very quickly identify the root cause of the issues by making the alert actionable, symptom-based, and context-heavy. So how do we get that feedback around? So how do we evaluate our alert? Let's zoom in a little bit on that. So there are some questions that you can ask, and you can also, as you fire an alert, a lot of the systems allow you to create links to next steps. So you can do something like link it to a Google form or some sort of feedback form to assess whether the alert is helpful. So you can ask questions like, is this alert helpful? What can be improved about this alert? You want to analyze the performance of the alert to check whether there's too many false positives or false negatives. And you can also implement this pull request culture. So in Terraform, you can make pull requests around the modules to see who's using them, who is utilizing. And you can track by checking what are they used for and how useful are they to the various stakeholders at your organization. So it's very handy to keep reassessing your alerts or your monitors, just making sure that they're useful, so you're avoiding those situations where everyone is you've created so many alerts that no one is looking at the alerts anymore. And then in the last section, I just want to talk a little bit about knowing your tools. And here we talk about tools in general that exist for the purpose of automating and standardizing and making a lot of your tasks repeatable and reusable. So this isn't just about Terraform, but it's the reason Terraform exists. If your systems offer access to various administrative and configuration tasks via APIs, you can automate a lot. And you can then implement governance checks and usefulness, or check the usefulness of your various configuration items and so on, using those APIs. So let's take a look at some examples of this. So you can enforce good governance by using things such as linting, for example. So there are lots of examples where, for example, alerts will go to Slack or email and then no one pays them any attention. So a more specific example that you can use is utilize something like linting or various other checks to make sure that when you set or when you define a notification mechanism for your alert, that it's going to a system that's going to route the alert appropriately, and that the alert is going to be looked at within that system. So you can force that level of governance to stop various notifications going to systems and maybe sometimes skipping on the process or good practices of then actioning the alert. I'll go into some deeper details around utilizing APIs within Splunk Observability Cloud and how we can also assess the effectiveness of our alerts more automatically. So in this example, we have a script called Alert Assessor, and it's hosted on our GitHub, so you can easily take a look at it, and you can download it. If you are a Splunk Observability Cloud customer, you can use that to assess some of your alerts. So for example, this alert assessor will check if your alert is too noisy or too quiet, whether it has any rules or notifications associated with it. What is it even doing if it doesn't, for example? And any other useful checks, like does it link to a runbook? Does it have a tooltip? Does it link to a feedback form? So these are all the ways in which you can automate some of the governance without having to have people manually check the alerts and then having to rely on just kind of sporadic and error-prone feedback by people. You can relegate that to machines to make sure you've got that assessment being done in an automatic fashion. Some other examples where we use APIs, you can do things like grab a list of dashboards and detectors, and you can check which metrics they're using and check whether the metrics that are being fed into those are actually useful or not. So you may have examples of a service that's has been decommissioned and is no longer or is no longer in use, has been superseded by another version, but is just hanging around somewhere, and you've got a whole bunch of detectors and metrics around it, and someone's getting notified, but then they is just creating extra unnecessary noise. So you can do a bit of a cleanup using the scripts. Another example of using the APIs is to check the number of dimensions that are being created. So you can have a metric coming from thousands and thousands of containers, but is that actually a useful way to group your metrics, and can you go up on a higher level dimension? So you can look at things like large dimensions, anything that's kind of creating a lot of that heaviness, and assess whether it's useful or not. And again, you can do that through API by pulling the data and running the scripts. So in summary, you can use the modern observability tools and the ecosystem around it, including Terraform has a lot of automation that supports automation of this governance, and of creating standards around your observability practices. And so creating this reusable components that allow your teams to mix and match what they need in this automated service fashion, without having to sort of rely on training people up and relying on them to do things themselves. So if you want to get started with Terraform, so I'm just kind of assuming that there's a mix in the audience. I believe that some of you would have used Terraform, maybe some of you haven't. So you can go to the Terraform website, and they'll have getting started tutorials. So you can start getting familiar with how to create some basic scripts, the useful commands, or the common commands that you can use. So there's a link there. And then we've got, so with the Terraform, we still use their old name, SignalFX, which is, if you search for SignalFX Terraform Provider, you'll be able to look in more detail around what's available. And then we have the free trial. So now Splunk Observability Cloud trial. So if you want to sign up, it's a 14-day trial. It will provide you with 2 modules out of the observability suite, which is the infrastructure, where you can send the metrics, and also the APM components as well. But if you want to have a practice of using that our Terraform provider, you can sign up for a trial, and then you can have a go at creating some of the alerts using Terraform and pushing them into the trial. So in summary, the Terraform provider and Observability-as-Code, it gets quite technical. There's a Terraform syntax around it. It facilitates a lot of things, but ultimately, what is the purpose of it? It's there to help with good design and good practices for setting up observability within your organization. It allows you to reuse and modularize where possible. It creates feedback opportunities for your team to keep reassessing whether your dashboards or detectors or any other setup within your observability space is effective and is useful. So we encourage you to use the governance tools to shape them by analysis and feedback, and ultimately enjoy them. So on this note, thank you very much for your attention and participation in this webinar, and let's open things up to Q&A.
Yes. Okay, we did have a couple of questions. I did want to remind everybody that if you do have a question for Kate, you can submit a question by heading over to the Q&A tab. First question, does Splunk have pre-built Terraform modules we can use?
Yes, so if you want to have a look at some Terraform modules, we do have a couple. We call it a proof of concept jumpstart. So we've got a bunch of modules for your AWS services, for GCP services, for just common host detectors and metrics. And again, we host that on GitHub. So we call it the POC Jumpstart, and there's a few examples there that are already available. And we use those a lot to get the customers started on Splunk Observability Cloud as well.
Excellent. And is this available on premise?
So the Splunk Observability Cloud, as the name suggests, it's cloud. So that's a SaaS-based service. But then the data collection and the Terraform, that would be hosted by you. So you just connect to the Splunk Cloud using access tokens. And there's details on the Terraform provider, how you can connect to it. And then once you can connect to it and run scripts against it, that's how it gets configured.
Okay, great. I'm not seeing any other questions. For now, I will remind everybody that today's webinar has been recorded. So if you missed any or all of the webinar, you will be able to watch it again. We will be sending an email with a link to access the webinar on demand, and you can also find it on devops.com. Just look in the on-demand section of the webinars page, and it should be there. To announce our 4 winners of the $25 Amazon gift card, our first winner is Stavros V. Congratulations. Our second winner is Gino T. Our third winner is Eric M. And our final winner is Umesh K. So congratulations to all our winners. We'll be reaching out to you via email with instructions for claiming your Amazon gift card. So please check your inbox. And if you don't see it there, check your spam folder. Kate, thank you very much for taking the time to put this presentation together and for giving us an hour of your time. I'm sure we all appreciate it.
Thank you, Julio. I think there was one last question that came through from Sal. It was in the chat. Does Splunk integrate with any other major communications platforms such as Microsoft Teams, Google Chats for additional collaboration? So we're talking about Splunk Observability Cloud specifically in this session. Yes, it does. So it does so in the context of firing alerts and sending out notifications. And also to pivot to Terraform, if you read the documentation on the Terraform detectors and the integrations, you can see there'll be a setup there, and there's various instructions on how you can send off alert notifications to those types of platforms. Thank you for that question.
Yes, thank you very much. All right. So we are at the top of the hour. So again, thank you very much, Kate. And I'd also like to thank the audience for their time and engagement. This is Julio Godinez signing off until next time. Thanks, everyone.
Thank you, everyone.